Today we're going to cover special segments in a circle, lesson 10.7. If two segments intersect inside of the circle, so either chords or we could talk about secants, then the products of the lengths of the chord sequence are equal. So if I look at this one, A times B would equal C times D. Now, if those segments intersect outside of the circle, we can have a secant, we could have a tangent, we could have a tangent and a secant, whichever way works, but they intersect at a point outside of the circle. If that happens, then we know that these are equal. That if you take the whole length, AC, and multiply it by AB, it will equal the length AD multiplied by, the length AE multiplied by DA. So in this one, it's the whole length of the secant times the portion of the secant that is outside of the circle. If you have a tangent and a secant, then we have the same thing on the secant, that the whole amount times the portion outside equals the tangent, that length squared. So I think the easiest way to study this is to look at some sample problems. So looking at the first one, we want to find x. They intersect inside of the circle. So we know that AE times EC will equal DE times EB. So 8 times x equals 12 times 9. Gives us 8x equals 108. Divide both sides by 8, and we get that x equals 13.5. And the next problem, we want to find x. So again, we're going to multiply the two portions. So x times x plus 10 equals x plus 4 times x plus 2. Distribute, we have x squared plus 10x. And we have to FOIL the next, so we'll have x squared plus 2x plus 4x plus 8. So we have x squared plus 10x equals x squared plus 6x plus 8. There's an x squared on both sides, so we can cancel those out because we would subtract it from both sides. Now we have 10x equals 6x plus 8. Subtract 6x from both sides. We would have 4x equals 8. So x equals 2. For the next problem, we have that they intersect outside of the circle. So for the first one, we have two secants. The length of this whole secant here would be x plus 8. The length here would be 10 plus 24, which is 34. So we take the portion outside and multiply it by the whole length, equals the portion outside multiplied by the whole length. So we have 8x plus 64 equals 340. So 8x would equal 276, and x equals 34.5. On the next one, we have x plus 24 for the full length. 27 plus 25 is 52. So we have x times x plus 24 equals 25 times 52. So x squared plus 24x equals 1300. Should read 52. X squared plus 24 minus 1300 equals 0. So now we need to factor. You know it's going to be a plus and a minus. We need the two factors of negative 1300. That will add up to be a positive 24. And that would be 50 and negative 26. So x equals negative 50 or x equals 26. Well, we can't have a negative measurement, so that one doesn't work. So x would be 26. Okay, so on the next one we have a secant and a tangent. This full length right here would be x plus 2, so it would be 2x plus 2. So it's the outside squared, 12 squared, the tangent squared, equals the outside times the full length. So 12 squared is 144. That would equal 2x squared plus 2x. So we have 144 equals 2x squared plus 2x. Subtract the 144 to the other side. We have 2x squared plus 2x minus 144 equals 0. They all have a common factor, which is 2. So x squared plus x minus 72 equals 0. We need the factors of negative 72 that add up to be 1. That would be a positive 9 and a negative 8. So x plus 9 times x minus 8 equals 0. X equals negative 9 or x equals 8. Can't have a negative number, so the answer would be x equals 8. Doing the next one, the entire length of this segment is 45. So we would have the tangent squared equals the outside part of the segment, the outside part of the secant times the entire length of the secant. So we have x squared equals 900. So we have x equals 30. And that concludes the lesson for 10.7. As you do the work, I would have this first page out so that you can see the different formulas that you need for inside of the circle and the two for outside of the circle.